There we go. Somehow skipped. There we go. Vocabulary here. Point-slope form. Okay, this is one of the vocab terms for today. If you recall, yesterday we learned another form. We learned slope-intercept form. So a little review from yesterday, slope-intercept form. Who remembers what slope-intercept form was? It was y equals mx plus b. And it was called slope-intercept form because it gives me the slope and it gives me the y-intercept. So henceforth, slope-intercept form. Today we're going to talk about point-slope form. Well, why do you suppose it's called point-slope? Because it gives me a point and it gives me a slope. So we get point-slope form. Now, point-slope form is kind of one of the toughest ones to graph out of, and you don't really graph out of it the most. But when you're writing equations, you start with point-slope form more than any of the other forms. Okay, because a lot of times you're given points or you're given a slope, so you'll always typically start with point-slope form. And that's what we're going to do here. So if you look over here, the equation of the line 210 with a slope of 3, it simply plugs it into that equation. Y minus y1 equals m parentheses x minus x1. And that right there is point-slope form. Okay. Now today we will work on putting it into point-slope form, which is relatively simple. It's some of the changing into slope-intercept form that some of us start to struggle a little bit, but really, if you can solve for y from there, not too bad. Okay, so point-slope form, and then we will work on a little bit of changing it into slope-intercept form. Okay, you will use point-slope form, again, more than any other ones, just to write equations, or to start writing an equation. Okay, it is more common in that aspect. Alright, so little review here. We're going to talk about finding slope using points. Does anyone remember the slope formula? It was on yesterday's vocab, I believe. The slope formula, though, was, anybody recall it? Not slope-intercept form. Slope formula? y2 minus y1 over x2 minus x1. And again, the key there is making sure you put the y's in the numerator, x's in the denominator. Okay, big key there. Make sure you don't switch those around. So if I use my points here, I have xy, xy. I just plug in my formula here. So -1 minus a -2 over -2 minus 3. Okay, well, just simplify that. Two negatives there get me the positive. So -1 plus 2 is 1. -2 minus 3 is -5. I have 1 over -5, which I will rewrite it into an acceptable form of -1/5. Why do I write it as -1/5 and not 1 over -5? Jack, why?
Because the negative just applies to the...
Yep, just put the negative in the numerator out in front. Don't apply it to the denominator. Okay? Same thing on number 2. Associate, you have xy, xy. So I would take 2 minus 5 over 4 minus a -1. Again, subtract my y's on top, subtract my x's on the bottom. So 2 minus 5 gets me -3. 4 minus a -1, those two negatives become a positive. 4 plus 1 gets me 5. I have a slope now of -3/5. The biggest mistake, again, I see students make on these is they want to put the x's on top. Y's go on top, x's on the bottom. Again, think about the rise, what you're going up, it's not vertical. Okay? Try numbers 3 and 4. Find the slopes of 3 and 4. Find those slopes. It's like, hey, we just did this yesterday, right? All right, number 3 here. What is the slope for number 3? What'd you say, Reagan? 1/3. Nice job. If you work it out, you actually get, I think it is like -7 over -21 if you go y2 minus y1. Well, -7 over -21, the two negatives cancel, and that's where we get that positive 1/3. Nice job. And my slope for number 4 is what then, Bailey? 2. Again, we get 8 over 4. That simplifies to 2, or 2 over 1 if you want to look at it that way. So a little review of slopes. Key part. Got to know that for an ESO test. Okay. Now we're going to talk about writing an equation in point-slope form. Okay. If you recall, point-slope form, y minus y1 equals m parentheses x minus x1. All right. So a little review of what that point-slope form is. Now, I want to write an equation that has a slope of 1 and a point of 0, 0. So I'm going to take that information and plug it into that equation. That's all it is. So if I look at my form here, I have x and I have y. So it's going to be y minus 0, taking that y coordinate from my point, equals 1, taking that slope, parentheses, x minus 0. And that right there is point slope form. Okay. Now, if I wanted to simplify that, which we will be doing later, if I wanted to simplify this right here, anytime I see that setup, I think what, Sage? Anytime I see that setup, I think what, Colin? That is distribute. Yes, thank you. So really, you just distribute there. You don't need the zeros. That kind of simplifies to just y equals x, really. Okay. Number 6, same idea. I'm given an equation. I want to write an equation. Has a slope of -3 and goes through the point -1/2, 5. So if I look at it, I have my x coordinate and I have my y coordinate. I want to use my slope and I want to use my xy. So I'm going to say y minus 5, taking that y coordinate in there, equals -3 parentheses x plus 1/2. Does everybody know why I have a plus 1/2? Because when I plug it in there, I get minus a negative. So those two negatives will give me that positive. So y minus 5 equals -3 parentheses x plus 1/2. And that's point slope form right there. Try number 7. Take a second here. Try number 7. All right, Sean, what do you have for your equation? Nice job. That is point slope form right there. Okay, and again, writing in point slope form, really not that bad. You're just plugging information in. But we're going to have problems like these. So number 8 says, write an equation of the line in point slope form that passes through the points 2, 3, and -1, 5. Well, in order to use point slope form, I need a point and I need slope. On this problem, I'm not given any slope. Okay, I'm just given 2 points. So what am I going to have to find here, would you suppose, Garrett? I need to find the slope. So using these 2 points, can I find the slope? Yeah, I need to use those 2 points to find the slope. So I'm going to take -5 minus 3 over -1 minus 2. Again, plugging those 2 points in, finding the slope. So I get -8 over -3, which -8 over -3 is really just 8/3. Now I have my slope. Okay? Now here's where students want to try and make this more difficult than what it is. In order to write it in point slope form, how many points do I really need? All I need is 1. Okay, so a problem like this, you could choose either point. It does not matter. Garrett, which point do you want to choose? 2. Okay, so let's use this point right here. I'm going to take that point in this slope, and I'm going to put it into point slope form. So what would that answer be in point slope form then, Garrett?
1 minus 3 equals 8/3 parentheses x minus 2.
That's it right there. Okay? And again, if I wanted to use the other point, I could use the other point. That's fine. Just make sure you leave y and x in there. A lot of times students want to plug both points in. Don't do that. Just plug one of them. Choose one. Okay? Same thing on number 9 here. I'm given 2 points. What do I need to find? I need to find the what, Sage? I need to find the slope. Very similar. I'm going to find the slope here. 3 minus 4 over 2 minus a -1. So 2 plus 1. 3 minus 4 gets me what, John? 2 plus 1 gives me what, John? My slope is negative 1/3. Now I plug that in. What point do you want to use, Jack? It doesn't matter to me.
Negative 1/4.
Negative 1/4. Let's use that point. So what would my equation then be using that point, Jack?
Y minus 4 equals negative 1/3 parentheses x plus 1.
You say plus 1?
Yeah.
Nice job. That is it right there. Okay, so the hardest part on some problem like that is making sure you have to find the slope. Okay. Try these two. Same idea. Find the slope first, and then put it into point slope form. All right, what's the equation you get for number 10? Mark, what do you have for number 10?
Y minus 0, or do you want me to?
Yep, that's fine.
Or
Yeah.
What?
Yeah, give me the equation.
Oh, y minus 0 equals 5/3 parentheses x minus 0.
Nice job. You can do that one very good. If you did the other one, be y minus 5 equals 5/3 parentheses x minus 3. All the same. Number 11, what do you have for number 11? Reagan, what do you have?
Y minus 6 equals parentheses x minus 1.
Nice job. Does everybody know why she didn't put a number out front there? What's the slope? So 1, right? Nice job. That works. All right, next part here. Little review from geometry terms. Hopefully you can recall some of this. But the key here is the slopes of parallel lines are equal, or they are the same. So if you look here, the two slopes, they are the same. Parallel lines have the same slope because they would never intersect. So they're going to go up and up and up and over at the same rate. Okay. Whereas perpendicular lines have what are called negative reciprocals. They can also be called what are opposite reciprocals. Now, if you recall from chapter 1, reciprocal was just where we flip it. We talked about using the refliprical. We flip the numerator and the denominator around. Now, the only difference here is they're negative or they are opposites. So one of them would be positive and the other one would be negative. Okay? So perpendicular slopes have one positive, one negative, and again, you flip them around. Okay? So we're going to use the same thing of what we know here. And we're going to use parallel and perpendicular lines. Okay? So here's kind of what it looks like here. Now this, again, the students said this earlier, but looks a little more confusing than what it is. We're going to use point slope form and what we know, because it's going to give us a problem that says, hey, write an equation of the line that is perpendicular to y equals 1/3 x through that point. Well, if it's perpendicular, that means I have a new slope, and my new slope would be negative or opposite reciprocals. Okay, so the opposite or reciprocal of 1/3, if I flip that around, is 3/1, and we put the negative, which is the same thing right there, so negative 3. Now I take that slope along with this point, and I plug it into slope-intercept form. Okay, and then from there we're going to work on, point slope form. And then from there, we're going to work on changing it into slope-intercept form. Now, if you look up there, pretty wordy, a lot going on. As we start walking through this, it's really not that bad. Okay, so let's look at the first problem. We're going to start with parallel lines first. Parallel lines are a lot easier. Now, parallel lines here, it says write an equation for the line that contains 4, 5, and is parallel to y equals 1/2 x minus 3. So I want this point, and if it's parallel, I know my slopes are going to be the what, Justin? Slopes are going to be the same. So I'm going to use the exact same slope and that point. And I'm going to plug it into point slope form. So I'm going to get y minus 5 equals 1/2 parentheses x minus 4. I plugged it into point slope form. That's what we've been doing so far. Now comes what we're going to add to it. I'm going to put it into slope-intercept form. So anytime I see that setup right there, what do I think, Sage? Distribute. So I take it, I distribute it, getting me y minus 5 equals 1/2 x minus 2. Now I just need to solve for y, so I'm going to add 5 to both sides. And I get my equation, y equals 1/2 x plus 3. And if you check, my slopes are still the same. They are parallel lines. Okay? So let's check number 13 here. Same idea. I want to write an equation for the line that contains 0, 5 and is parallel to y equals negative 2x plus 4. So I'm going to take this point. Parallel lines have what type of slopes, Bailey?
Wait, what?
Parallel lines have what type of slopes? The same. The same slopes. So I'm going to say y minus 5 equals negative 2 parentheses x minus 0. And again, anytime I see this setup, what do I think, Sophie? I distribute. So I distribute there, getting me y minus 5 equals negative 2x. From there, I just add 5 to both sides.
Please come to the office. Sydney Burke, please come to the office. Thank you.
And I get y equals negative 2x plus 5. And what do I check? Well, my slopes are still the same. Hey, that's a parallel line now. Okay. Next two, a little bit tougher, but that's just because we're going to talk about perpendicular lines now. So perpendicular lines, are my slopes the same now? No, they're not. So I want to find a line that's perpendicular to y equals negative 4x. So here's my slope. What's my new slope going to be here? Andy, what do you say my new slopes are going to be? Very good. 1/4. Because it's a negative or opposite reciprocal. So that's my new slope. So I'm going to take that slope along with this point. I'm going to plug it into point slope form. So I get y minus 3 equals 1/4 parentheses x minus 2. Anytime I see that set up on the right, what do I think here, John? So I distribute, getting me y minus 3 equals 1/4 x minus a half. Add 3 to both sides, and I get y equals 1/4 x plus what would be 2.5. And there's the answer. Try number 15 here. Try number 15. All right, let's walk through this here. What's my new slope going to be? Sean, what's the new slope going to be? Yeah, it's negative 1/3. So I take that negative 1/3 along with this point. I plug it in. In point slope form, what would that look like then, Sean? Very good. Then when I work it all the way out and put it into slope intercept form, I get what, Sean? Nice work. That is correct. That's it right there. Good job. And here is your assignment.